Hello, everybody. It's Damon. Crazy Logics on the forums and Crazy Logics 007 on YouTube. Uh, we're going to go part two here. It'll be a four-part series on this little machete. This is old footage I did, so yes, it does include that awesome bonus bald head material in this old footage. That's just, a bonus feature. Uh, but I was working towards making the next set of videos for old school amps, and everybody was wanting this Rockford, and I'm sorry to tell you that this Rockford is not going to be happening right now. This was the big 801S, and the transformer got really crispy, like super duper hot, and probably is wrecked. There's the lid where it was. It got so hot that it's just destroyed that. So there was definitely a power supply issue. Plus, you can tell where these have been heated. These are all discolored and stuff. And I don't have a parts board for this size one yet. So when you overheat a inductor like this so much that you cause all this, I mean, you just can't even believe how much how much heating you can tell. And if I look at the back side, looks like the solder's even kind of come undone. You run the properties of the inductive core that this is wrapped around, the ferrite core, and so I will have to either source a parts board that's destroyed so bad down here that it's not worth saving, and still has a good either fully wound inductor or at least a good core, so I can rewind it. So one of those two things I'll have to figure out, either rewind it or find a parts board for it. But this one's a no-go right now because I don't have those. I just wanted to let you know so that when you see the others come on, or the other videos come up and you wonder why this isn't here, well, that's why. So on the machete, in part one we left off, we had just taken all the outputs out and we were finished cleaning up the board, and we're getting ready to make sure we don't have any shorts, any solder bridges and stuff from removing all the old FETs and everything, so that we know that everything's all good to do a power up test with all the outputs out, and that way we can go from there. So here's part two, like I said, of four. It'll jump right into where we're getting ready with the multimeter to test that stuff, and like and comment and subscribe and all that good stuff. I hope you learned something, or you at least enjoy the bald head footage. And I will continue to work on getting some more of these old schools going, and we'll rely on when I'm having issues like this, we'll rely on some of this older footage I shot with my cell phone, so hence not as good as maybe some of this newer stuff I do. But thanks again for watching, and on to the video. On diode mode, I thought we did. That's my oscilloscope probe. That would be the other correct probe. Hey, it works, look. We're not getting anything crazy. It's just like quick charges of the capacitor. So start with this little bank. Like I said, I like to try to take these out, and let's make sure, yeah, you can see those, and kind of leave them laying there. So if let's say all those were good but one, I'd go back and look at where that one was to make sure driver resistors, any clamping diodes or bleed off resistors in that area weren't bad. I'd pay extra attention to it. I'm going to check all of them anyway, but paying extra attention. So that one comes up as a FET 2.24 and 3.9 volts. So 2.24 nanofarads and 3.9 volt. So this is going to be our little write down here. Get a paper towel to keep wiping the stuff off. So we got 2.27, 3.9. Can you see the tester? Yeah, you can. 2.29, 3.9. So, you know, those were looking good. .27, 3.9. Boy, unless this last one's the dead one. May have issues on the board or with driver circuit or something. Oh, that one says dead short. It's making my tester go into test mode. I don't want it in test mode. There we go. So, we got the multimeter, and we'll stick it here, here. That's good. Here, here, here. That's good. Here, here. That's good. Here, that's good. And we got a dead one right there. And that came out of that spot right there. Sharpie out. Put your little dot. So while we got the multimeter going, nothing. And that one's short. So that came out of this hole. So we're going to dot it. And then going ahead, these four supposedly are good. I wouldn't necessarily call them good, but these are the other four that should be good. And this one, based off the diode test, is bad. Make sure we're still on the camera. Yeah, we are. 2.25, 3.8. That's not bad. .27, 3.9. It's hard to write nice and neat. Sorry, when you just kind of do it one-handed and get all flipped out there and you're just scrawling on a loose piece of paper. I'm just looking to make sure these are close. Get a little hole down there, 2.26, 3.9. See, these are all testing good. .25, 3.8, and this one should show a dead short and should throw my tester into test mode, or calibration mode. Sorry, you normally clip all the leads together. Yep. It says prepare capacitor. We're in test mode because that's a dead short. It thinks all the leads are clipped together. All right. So had two dead transistors. So one thing I'm going to do is So I got all these and I got all these. I'm gonna let the batches. And then also the two dead ones here. Find my cheaters here, because I'm not as young as I used to be. So is this an 8AC TP638P? Yep. Well, they all match up. Alright, that makes me a little suspicious of stuff on the board. Two dead ones. 4 plausible good ones from each bank, which is really a good thing, because that should, if everything tests out fine on here, give us some test fits. Power this up, make sure it doesn't go into protection anymore. Now, these are all matched batches, so technically, if everything works out and nothing else is bad and shorted, but I gotta really test these two right here, and I need to check those diodes right there. But let's assume somehow we had 2 bad fits, one on each side, right by these diodes, which I'm a little sneaky about those diodes. That, and there's a solder ball right there. That was on top of that. I'm going to look at that. But let's just assume that somehow we had 2 bad fits. And when first went to power it up, they were junk and they died immediately and kicked it in to protect from the factory bad. You know, 2 bad fits. The factory probably gets, hundreds of thousands. Who knows how many of those fits? Maybe millions, depending on how many amps they're producing. So, they get some bad ones. The fact that we had one on each side right out there, baguette. Some weird coincidences, I don't know. But let's say we test out all this stuff. We throw in fits, everything checks out good, it'll play, it's not dying. Technically, since these are all matched, if you were trying to save money and we didn't think these had really taken a hit or damage, we could put 5 matched ones in here and only order 5 matched ones for over here. And that should work. However, we'll have to look and see how much these are. I don't think they're a whole lot. As a matter of fact, I can pull it up real quick. Yeah, depending on where you order this fit from, $1.50 to down to $1, depending on what kind of quantity you're ordering in and stuff and who you're ordering it from. Plus you got tax, shipping and handling and all that. But so, you're looking at this and let's say you're getting them at roughly $1 plus tax and shipping and handling, which, shipping and handling kills you and all that stuff. But let's say, that's $10 shipping and handling, and in all my minimum orders always end up being, no matter what, the cheapest shipping I can get is $8. And you figure tax is a little coupled up, $1 or $2 or whatever. So $20, let's just call it, just for the parts to get them to you. If this was all you were fixing, you might be able to find some place with a little cheaper shipping and handling. But I always buy from reputable suppliers, so let's just say $20 just to get the fits. You've done all this other work, and we're going to use these to test. We know it's going to all, we test everything, it's all going to be good. $20, you charge whatever you do for labor if you're trying to do this for a living and you're running a business. I'll contact the owner and tell him, it's going to be $10 for the fits plus tax plus shipping, so it's going to be at least $20. Hopefully he'll say, hey, I'll give you 30 or something like that, and I can order up some more of these for a total of $30. He'll pay me for all the parts, all the tax and the shipping and handling, and then he'll just give me the spare FETs to put in my drawer to have for next time in case, you know, I need them for that. That's kind of how I do this, because I don't do this for a living. So I'm just doing it to try to build up some inventory, learn, because I love electronics. I love repairing things. I'm a big right to repair advocate, and I wanted to do a bunch of YouTube videos as payback, you know, pay it forward to people who, you know, have helped me when I've watched YouTube videos. I have to take a laptop apart without breaking all the little plastic catches so I could replace the charging jack in my wife's laptop. I knew how to replace the charging jack real easy. That was fine. I just wanted to see how they took it apart so I didn't tear nothing up. You know, I've watched countless videos on little nuanced things on to fix your car and, you know, this and that and stuff. And so it doesn't matter if you make a good video, if you know how to fix something and can make a video of it and post it on YouTube, somebody will find it from a search, and if it helps them out, you're paying it forward, saving them money. I'm a big believer in that, so that's why I keep doing this. You know, if I do it for 20 years and get good at it, by the time I'm ready to retire, then maybe I might turn it into a business, you know, like a 3-day-a-week business or something like that, because I enjoy doing it, and I surely wouldn't want to retire and just sit on the couch. So, but that's many years down the road. So we're going to set up to test all this stuff first, then put in this should be a bank of 5, so we should only need 1 on each side. We'll make sure everything's good, put 1 in, test it, make sure it doesn't happen, and I'll come back to you kind of when I'm a little more prepped for that. All right, so we got a bunch of little resistors that drive the gates of these FETs, and they show up as 10R0. I got a little app on my phone, which my phone's doing my recording, so it makes it a little tough, but during the break I looked those up. That's 10 ohm resistors. So we're going to turn our little tester here to ohms. That's 10.2, 10.2, 10.3, 10.2. Those are testing all pretty good. 10.2. I can get my probes on there. 10.3. Yep, 10.3. 10.3. 10.3. And the last one where we had air problems, 10.3. So we're going to go to diode check, and there's the lines on the diodes. That's the negative side. So we put that in, we test 202. On this one, that's the negative side. We conduct through and test 202. The other way we shouldn't conduct, but we might charge the capacitors. Yep, we are charging a capacitor there. Put in opposite, and we are charging capacitors. All right, so that's good. So we also have one little bleed off resistor here and a little bleed off resistor there, and it is a 1002, which is 10K. So we're going to measure that one. Try to get to where you can see this. So much harder to repair amps when you're trying to 1.8. Is that 10K or 100K? 1002. Let me look at it again. $10K. it is 10K. So we got our meter on 20K. We're reading 1.8 there. That doesn't sound good. 9.4. So that's 10K. Now this one over here. Oh, there we go. 9.90. That looks good. Just had to kind of get through their solder goo. That's the one thing about the lead-free solder is it seems like it forms a nasty oxidation that makes it really tough. Got a couple holes we need to clean up here. But everything looks good. So I'm going to cut away. I'm going to hook up some power. We're going to see if it still goes into protect with all these out. Make sure nothing overheats. See if we can find some drive signals. Feed it some RCAs. Try that. If that doesn't work, then we'll put in a pair of transistors to properly load it and see if we can see the drive signals. So give me a minute to set up and I'll be right back. So one thing I'll give this Machete amplifier, all these screw terminals, even though some of them are big and some of them are little, all use the same size set screw with the same size Allen head. So you only need one Allen wrench to install this thing. That's handy. That's a nice little feature. You know, I really like it when they try to do something nice for you and make it simple. As a matter of fact, I think from the factory, these may even come with an Allen wrench in the instruction manual. I could be wrong. We're going to go ahead and apply a little power. We're just going to blip it for a second. And then feel the backs of these. Make sure they're not getting hot. And looky there. Let's see if you can see that. Yep. No protection. The on light is on. So the dead short was definitely in the outputs. Probably those two. And it doesn't go out. And now we're going to shut her off. And feel for heat. No heat. That's a good sign. Turn off the power supply. That tells us at least nothing is sucking current down so hard, even with the output FETs out, that these are heating up for any reason. I've got a couple places on the board here that need to be cleaned up. So we can put FETs back in. Cleaned up nicely. And that one cleaned up. All right, excellent. All right. So we're going to take two good FETs. Clean up the ends of these so they fit through the hole real well. Stick one in there. Still got a little booger on the end. Sometimes you'll notice these are burred. If they don't drop out super easy when you heat them, they might have little burrs on them. Okay, so we're not worried about height, install height or nothing. We're just going to hit them with one shot of solder. Oh, got a little fur out. There we go. Hold it in place. looking for perfection here. Just no solder bridges. Get that fit in place. Turn the old multimeter to continuity. My wires have got all twisted and turned here enough that they're fighting me. I'll get my multimeter leads off here. Alright. There we go. A little short there. Nothing there. Charging capacitor. That looks good. Alright, phase 2. Powered up with a pair of FETs in the board for just a moment. Kick on the power supply. Just going to power it up for a second. Oh, flashed good. Those are nice and cool. Those do not feel warm either. You have to be careful if you just solder them in. Sometimes they'll feel a little bit warm, depending on how much you had to solder. So kind of get a reference to yourself. So we're going to go ahead and fire this up, and we'll give it to 1, 2, 3. Does not feel like it went warm. Those don't. Everything's nice and cool. So I feel safe. Powered up a couple little blips to check the power supply. All right, so I'm going to pull you down here. We're going to, we're going to first test them on all the backs, which is the center leg. Then I'll show you the little drive part right there by the drive transistor. Make sure my probe's not all dirty. Let's go right here. The oscilloscope. Nothing's got warm. So we're turned on. There is the powered wave. I'm going as fast as I can. On the backs of all the FETs on the power supply. Alright, let it cool off just in case. I'm feeling nothing got hot. So now I'll show you the drives. There the drive wave formed. And they all got that tiny little dip, which is okay. Because our main power looks nice and square. That is awesome. And so I'm checking. Nothing's hot. All right. All right, we gotta bring you back down. We're gonna check the low side drive. I believe is on the gate, and then on the high side, if it has it, will be on either the positive or the gate. We'll see here. This one, no RCAs. Let's see if this one's self-oscillating. This should be the positive pad.